on magnetic circuits. On the last class we have started solving a few. Let me share the screen. Hope my screen is visible to you. Okay, so in today's class we'll try to solve this problem. You see there is a magnetic circuit with metal of permeability mu r equal to 1300, and for that we need to solve the air gap. We need to solve the magnetizing current. This is our I current, and this current should have such a value such that in this air, this is your air gap. So this is actually iron or magnetic material, whatever it is, and there are a few lamination with which you got this, and there is a air gap of small length of like it's 0.1, uh, and that is in millimeter. So then what is our magnetizing current, for which through air gap we get a 1.28 milliweber flux through this air gap. So phi is given to you, and these are the your specification. That means what is the length and what is the thickness, what is your breadth, so that you can find out your cross section area and all this. So those you have to calculate, and accordingly you have to get your overall uh, reluctance. And once you know reluctance, once you know flux, then uh, you can find out your mmf. And if you know the number of turn, it is given 200 turns in this coil. So from that you can calculate your current. So let us solve this now. Okay, let me do it in your, there is one whiteboard. Actually every day I am sharing the whiteboard uh, from the external app. So let us try it here. If it's not working, then we'll go back there again. So here, what is our problem? Our problem is like this. So we have a circuit. This is our magnetic circuit. Here is our coil, which will be carrying a current I. Number of turn is 200. So what is your total mmf? It is equal to 200 I. That is our mmf. Now through this path, flux line will be originating from here, and it will be having two different paths, and it will come close the circuit like this, just analogous to a electrical circuit. So if we draw the circuit, then it will be like this. This is your mmf. Like if we draw the electrical analogy of this path will have certain resistance, so it will be actually reluctance. So this is say S1, this is your S2, this is for air gap SG, and we close it like this. There is another thing, so as a whole we can put it here for this path, then through this path, through this path, through this path. So we can write S by 2 here, S1 by 2, S1 by 2. So as a whole we can put S1 for this path, and for the another path there is no air gap, so let us take it as S3. So what is given, this phi, if this is your phi 1, if this is your phi 2, your phi 1 is given. Phi 1 equal to 1.28 milliweber. That is given to you. Let's just check once. This is your phi 1 through this, and this is your phi 2. This is your phi 2, and phi, if this is your phi phi is equal to phi 1 plus phi 2. So what we can tell that up to this path, for flux line to flow through this path, we need a MMF which is equal to MMF for uh, path 1, say MMF 1 is equal to S2 plus Sg into phi 1, and that should be same as equal to phi 2 into S3. Agree? Because MMF in this path is same as MMF in this path, just like your V equal to I1 R1 plus equal to I2 R2, same way. So if you now calculate what is your S2, Sg, S3, then you can get the ratio between phi 1 and phi 2. Once you get the ratio between phi 1 and phi 2, you can get the overall expression of phi. What is your phi? Then phi into S1 plus this drop will give you the total MMF, isn't it? So let us now gradually calculate what is your S1, S2, Sg and all those things. S1, let us first take S1. S1 is this path. So what is the, we have to take the mean length. So if it is 500 and the thickness here it is given 60, here also it is 60. So 30 we should leave half of that, half of that. So that is the mean, like you can see the central line I have drawn here. So this 30 and 30 we should ignore, and then we should take the mean value. So it is, instead of 500 we should take it as 440 millimeter. So this length plus this length, which is 170, because it is 200 200 400, again 30 30 we leave, so it is 170. So 170 400 170, that is your overall length, right? And what is your cross section area? This is given, this is 40. So 40 and this is equal to 60. So 40 into 60 will be your cross section area. So let us now do that. So for S1 it is 1 by mu 0 mu r into L by A. So L1 by A1, whatever it is, we can write. So it is 170 into 2.
Sir, your screen is lagging, I think. It is what you're writing is not being displayed.
Actually, I don't know, for few days our institute net is very, server is very down. So please try to manage it. So what I am trying to do, I am writing this. What is the length for this path? These are the two paths. This is for phi, this is for phi 1, and another is for phi 2. Can you see this? Can you see the PDF PPT?
PPT? Sir,
Yes,
we
sir.
can
We can
see
see.
Yes, sir.
the PPT is frozen, sir. We can
PPT I am not changing. It is just like displayed the problem. Solution is there. Now I am changing here. Can you see the solution now?
no, sir.
Is it changing slides?
Yes, sir. The slides is changed.
Okay. Okay. So what I am trying to do, I am trying to find out the length of this path, one side. So it is what? Uh, it is 170, then 440, 170. This is the mean length, and then cross section is 40 into 60, because this is 40. So 40 into 60 in that way. So that I am actually trying to write here. So 170 into 2 plus 440, this is your length. Then this is mu 0 mu r, that value I'll put later, into cross section area. This is in millimeter, so we'll change it to meter. And another is 40 into 60, that is the cross section area, into 10 to the power minus 6. So this is your S1. So if you calculate that, that is solved actually in this PDF. So this is supposed to be, it is written in the other way, S, where is your S? Anyway, let us do it afresh. So what is the value of this? 173, 340, 440. So 780, isn't it? 780 by mu 0 mu r into this is 2.4, like that. So this is your S1. Similarly, we can find out that if this is your S1
Why
and
S1 is 170 into 2 plus 440 length?
because it is there in, if you look at the I mean figure, this is your 170, right? The total is 200, 200, 400. From each side you are taking 30 minus for the mean circumference. So 400 minus 30 this side, 30 this side, so it is 60. So it is 340. So 340 divided by 2 is equal to 170. That's why here it is 170, there also it is 170, this length. So for the S1 we are taking this entire length. So this is 170 plus this is 440 and then again 170. That is why 170 into 2 plus 440. Got it? So it is 780 length.
Sir, yes, sir. Yes.
Cross section is what? Cross section is, here it is 40 and here it is 60. So if you take the cross section of this is 40, this is 60. So this is your cross section area, right? So that is what? 40 into 60 into 10 to the power minus 6 meter square. So it turns out to be 2.4 into 10 to the power minus 3 meter square. And this is 10 to the power minus 3 meter. Okay. So then what is your S1? S1 is equal to 1 by mu 0 mu r into L by that. So L is 780 into the power minus 3 and this is 2.4 into 10 to the power minus 3. So you're left with this. This mu 0 mu r will substitute later. Let's see at the end maybe. So it's 2.4 like that. So this is your S1. If you calculate S1, then S1 is nothing but equal to S2, isn't it? S3 rather. I have written there S3. So this is your S3 and this is your S1. These are symmetric. If this is S1, this is your S3, right? Do you agree? Because this is also 170, 440, 170, and here cross section area is same as that. This is your cross section area, 40 into 60, right? For the central path, for this path, we have air gap as well as this. So total length is what for this path? It is, you can again take the average thing, which is 440. So 440 minus 0.1. 0.1 mm is your air gap length. So 440 minus 0.1 into 10 to the power minus 3 meter is your length. Cross section area A equal to 40 into 40, because if you take cross section, this is 40, this is also 40. So 40 into 40 into 10 to the power minus 6 meter square. So it is 1.6 into 10 to the power minus 3 meter square. So what is your then your S2? S2 is equal to 439.9. You can write it almost 440, no issue. Mu 0 mu r into cross section area, which is 1.6 10 to the power minus 3. Here also 10 to the power minus 3. That will cancel out. So you are left with 439.9 by mu 0 mu r into 1.6. So that is your S2. And next is to find out your Sg. Sg is equal to 1 by mu 0. Mu r will be 1 into length is 0.1. So 0.1 into 10 to the power minus 3 divided by 1.6 into 10 to the power minus 3. Okay. So this is your, or rather we can write in this form that it is uh, mm, mu r into 0.1 divided by mu 0 mu r 1.6. So once you have all this, what we can go back again to our calculation, what we are doing here. So we got our S1 and we got our S3. So S1 equal to S3 equal to 780 mu 0 mu r 2.4, and you have S2 S2 equal to 439.9 by mu 0 mu r divided by mu 0 I don't know why it's not writing. Let us write there. Sorry for the inconvenience. Just a minute, please. I cannot write in a new page, so let us continue there only. I'll just redraw it. So this was our 200i. This was our S1. This is S2. This is Sg. This is our S3. So what we got, S1 equal to S3 equal to 780 mu 0 mu r into 2.4. This is one. Another is S2 is equal to 439.9 mu 0 mu r 1.6. Sg is equal to mu r into 0.1 divided by mu 0 mu r 1.6. So S2 plus Sg is supposed to be 439.9. Mu r is 1300, so 130 we can write over here, divided by mu 0 mu r 1.6. So what I told, phi 1 into S2 plus Sg is equal to phi 2 into S3. So this is our total phi. This is your phi 1. This is your phi 2. So you know what is your S2 plus Sg, phi 1 into S2 plus Sg. What is your S2 plus Sg? It is 569.9 divided by mu 0 mu r into 1.6. That is equal to phi 2 into 780 mu 0 mu r 2.4. So that is why I didn't put their value. So you can now find out easily what is your phi 2. Phi 2 is equal to phi 1 is given 1.28 milliweber into 5. You can approximately write 570 into 2.4 divided by 780 into 1.6. So it is 3/2. So now you need to solve it. So it is 0.64 into 57 divided by 78. So let us solve it. Okay. No, I did the incorrect way. Sorry. Calculation part is wrong. Phi 2 will be equal to phi 1 is given. Phi 1 is equal to 1.28 milliweber into 570 by 1.6 into 2.4 divided by 780. Okay, so we can calculate this as 1.28 into 1.5 into 57 divided by 78, and that came as 1.4.
Sir, SI unit of phi is Weber only, na?
SI unit of phi.
Phi.
Yes. Here it is given as milliweber. So this is milliweber, or we can write 1.4 into 10 to the power minus 3. Okay. So now what is your total? You know what is your phi 1, that is equal to 1.28 milliweber. You know what is your phi 2, it is 1.4 milliweber. So what is your phi? It is the sum of these two, so it is 2.68 milliweber, right? Or 2.68 into 10 to the power minus 3 Weber. So now what you have to find out, you have to find out the MMF. So this MMF, total MMF required, which is your 200I, that is equal to this phi into S1 plus phi 1 into this, or phi 2 into S2, S3. So that you need to solve. What is your phi into S1? Phi is 2.68 into S1. S1, now you need to use their value, mu0, mu1 thing you have to use. So let us now solve it somewhere else. This is the part of MMF1. MMF1 is equal to 2.68 into 10 to the power minus 3 into S1 is equal to 780 by 2.4 into minus 4 pi 10 to the power minus 7 into 1300. Okay. So can anyone solve this? What is the value? It is, let us do it part by part. 2.68 divided by 2.4. It has come as 1.1167.
Sir, in my calculation, I is coming as 2.65 ampere. The value of I.
Value of phi.
No, sir, the current that is 200.
Magnetizing current. So can you tell me part by part, what is this MMF drop? This is actually 1.11, or let us do it. So into 780 divided by 4 pi.
Sir, the value of phi is, I have calculated the whole thing. The value of phi is coming as 198943.67.
Phi or MMF here? Drop across this? Oh, okay. You have
Sir.
not done in this way, is it? Let me check what is the value.
Yes.
It is solved actually. Value has come to be something. 3.34. How much you got? 2 point something.
Sir, I think I have made mistake then. 2.65 I have got.
Maybe some lot of calculations are required actually. So
Yes,
thing
sir.
is like this: if you solve this, you will get the drop across here. And for the phi 2, this part, this is actually phi 2, we know 1.4 into that S3. Same value you should put. Okay. So in that way, it is possible for you to solve the total thing, total MMF required. So once you calculate this total MMF, that if you divide, if this is MMF1 and if this is MMF2, so total MMF is equal to MMF1 plus MMF2, and that you should now divide with 200, which will give you the magnetizing current. So this is the approach. So you please verify. I'll share, I mean today only I'll share this thing, whether I have done it correctly or not, that you share, that you check and let me know whether it is done in a proper way or not, whether the calculation, I think I have verified it with the answer key. I mean, I have cross-checked from the exercise. Answers will be provided in some book. I don't remember which book. So I cross-checked. I got the answer, I think. Anyway, it is left to you just to cross-check whether calculations are correct or not. Let us now take a different problem. Here it is the other way around. So you have a similar parallel circuit, but instead of single air gap, you have two air gap. Here you have given a coil of current I, which is equal to 1 ampere, and number of turn is 300, and the length are given. This is your air gap. Air gap length is both side, it is like that. And this is your mean area. So this length is given. This is of 5. This is 5, and your or rather we can write it like this: the mean length is given. You don't need to calculate the mean part, so it is 200, and here it is 150. So cross section area is given as 5 cross 5, that means 25 centimeters square. So now it is told that what should be the value of mu r for this, what kind of material you will use for this particular magnetic circuit, so that you get a 20 milliweber flux in the both the aircraft. Ig, air gap flux, equal to milliweber. So that is your problem. So you can see that it is a symmetric circuit and both are same. So this phi will be divided into 2, right? If this is phi here, that will be phi by 2 and phi by 2. Why? Because air gap length is same, and the effective, it is symmetric about its axis. Therefore the length will be similar, means length similar, cross section area area is same, so we can say that we'll have the same reluctance. So if the reluctances are same, then we'll get the same phi in both the branches, right? So what is that? 5 by 2 is given, which is your phi g, or if phi g we can take, then the central limb will have a flux phi equal to 2 into phi g. So it is 40 milliweber. So now we have to calculate what material we should have so that we'll get this flux. Then what is our effective circuit, equivalent circuit? We can write it like this. MMF equal to what? 380. Then what we have for the central path, there will be a reluctance. Then this is your S2, this is SG2, and the another one is S3, SG3. So this is your equivalent circuit. Then our task is to find out your S1, S2, S3, SG. So S2, S3 and SG2, SG3, they are same. So we can write it at a time. S1 is equal to, for the central one, it is 150. So 1 by mu 0 mu r into 150 into 10 to the power minus 2 divided by, what is your cross section area? It is 25 into 10 to the power minus 4. Okay, so that is your S1, and we can write it in the form as it is 156 into 100, that means 600 divided by mu 0 mu r, right? This is your S1. What is your S2? S2 is equal to, for the entire thing, 150. Out of that, if you take out 0.01, then almost you can take it as 150 only. And what else you have? These two. So it is 100 and 100. So 100 into 2 plus 150 is your effective length. This is 100. This is total 150, and this is 100, because 0.01 we are ignoring. So that is your length divided by mu 0 mu r into 25 10 to the power minus 4. There it is 10 to the power minus 2. So it is 350 into 100 mu 0 mu r 25. So how much it is? 14. So it is 1400 divided by mu 0 mu r, and S2 is equal to your S3. What is your SG1, SG2? SG2 is equal to 0.01 into 10 to the power minus 2 divided by mu 0 into 25 minus 4. So what we are getting, it is 0.01 by 25, or rather we can write it is 1, because 0.01 into 10 square, that means it is 1, 25 mu 0 mu r. So actually what we are getting here in this part, then effective reluctance is 2 plus is G2 is equal to mu 0 mu r plus this is 0.04 mu 0 mu r. So 1400 0.04 mu 0 mu r is your total reluctance. So then what is your you have to now balance it. So your total MMF is 300, then this S1 is 600 into mu 0 by mu r into your phi. So phi is equal to 40 milliweber. So 40 into 10 to the power minus 3 plus this is 1400 into 0.04 mu 0 mu r into, this is 20 milliweber for this path. So it is 20 into 10 to the power minus 3.
Sir, one thing,
Hmm.
sir, mu r for air is to 1. So we'll take mu r as 1 here. S2 plus Sg through in the bottommost line which you have written.
This will be 0.04 mu 0, sorry. So it will be, in that case, it will be that into mu r somewhere here. So we can write as 1400, rightly pointed out. Okay. Agree. So this accordingly we should put 1400 plus 0.04 mu r, or you can write mu r by 25, whatever you feel like. That you have to solve now. Now you should put the value of mu 0, and then we can take mu 0 common from the denominator and take in the other side. So in the next slide, what we should write, next step. So it is 300 mu 0, right? And that is equal to how much we got. Can you just repeat what is there? It is 600 into 600.
Yeah.
If we take mu r in the other side, then it will be what? 600 by mu r, isn't it? Plus it is 1400 plus 0.04 mu r divided by mu r. Am I correct? So then it will become 300 into 4 pi into 10 to the power minus 7. So 600 by mu r, then 1400 by mu r, then 0.04, right? So this here will turn out to be, let us calculate this. It is 4 into pi into 300. So it is 0.00377. That is equal to this 600. So it is 2000 by mu r plus 0.04. So actually the values are not up to the mark. I think I have taken centimeter square, it should be millimeter square. That's why it has not come. So it will go in other side 0.04, and that is equal to 2000 into mu r. So it is coming as negative. That is not actually a right thing. So it will come like this, 2000 divided by this. So if we take some, if it is that zero error is there, so if we get some value here, so that will give you the total mu r. So this is how you can solve it. I think I have, while copying, I have taken centimeter millimeter that issue. Because of that we are getting negative here. So this is how you can expect problem. Like mostly it will come as what is your magnetizing current, and uh, mostly the problem will come like that to find out, so that you can generate develop a flux in the air gap, and that air gap flux will be given, or you will be given in the other way. It will be given what is your magnetizing current, and you have to find out the air gap flux. So that is also possible. So always, whenever you are getting the circuits like this, you will always be having a electrical analogy for that particular magnetic circuit, and you can solve in that way. So if you wish to, I just want to show these things again. So if we have a parallel circuit like this, you can use the concept which we use in case of Ohm's law, like the way we reduce the parallel circuit. Let us just show that once. Say you have a circuit, magnetic circuit with MMF like this. Some MMF Ni is given, and this is your S1, this is your S2, This is your S3. So how I am solving the, how I am writing the total MMF here? If this is MMF 2 and if this is MMF 3, if this is MMF 1, then what is MMF 2? MMF 2 is equal to phi 2 into S2. This is your phi 2. This is your phi 3. This is your phi 1. And MMF 3 is equal to phi 3 into S3, right? So what we can write from here, these two MMF are same because that is the effectively in the same path, one point to another point. If we take a unit north pole, then work done will be same for this path as well as this path because the phi's are different. So once you have that, then you can equate these two like the way we are solving it. Phi 2 S2 equal to phi 3 S3. So phi 2 is to phi 3 equal to 3s3 is to s2, that we can write. And what else we can write over here? Total mmf is equal to mmf1 is equal to phi 1 into s1. So what is your phi 1? It is phi 2 plus phi 3 into s1, right? So what we can write? We can write phi 2 in terms of s phi 1, because total is phi 2 plus phi 3 is equal to your phi 1, isn't it? So then your phi 2 in terms of phi 1, how can we write? It is s2 into s2 plus s3. And another one is s3 into s2 plus s3. That also we can write. Okay. So this is your MMF here. Then what will be the effective thing? What is the effective resistance for this path? Or sorry, reluctance for this path? What is your effective reluctance for this path? We can write it in the form of
S2 by S2 plus S3. So that only, no?
because you can write like this. It is what is your MMF? MMF is same. MMF 2 and MMF 3 is same. So that by S2 plus mmf 3 by s3 is your, if total is the mmf is same, if that is x, uh, then that is your s equivalent. So then you arrive at the same equation, s equivalent equal to 1 by s2 plus 1 by s3. So s equivalent is equal to s2 s3 divided by S2 plus S3. Just like the parallel combination of the resistors, the same concept you can write here also to find out the effective reluctance, and that you can add with this one. So S1 plus S equivalent, and in that way also you can solve. So I would ask you to cross check whatever problem, the first problem which we have solved now, the first one, if we take the same approach of our solving our complicated resistive circuit, we should arrive at the same result. So that also you can cross check.
Sir,
Just to
I have
verify.
cross-checked the first one. I have
Uh,
actually calculated the equivalent, what we say, reluctance. And
mm.
from that, sir, I am getting the value of I as 4.035. But error is there. Margin of error is a lot because your was 3.67 something.
No, marginal error should not be here actually. It should accurately match. It is not any approximation. No? We are working in the same way with the same concept, isn't it? Because we know that at these 2 points MMF will be same. Because of the parallel path, at these 2 points always MMF will be same. So that means what? The same concept, your I1 into R1 equal to I2 into R2, just like your
Yes, sir.
same way we can write phi 1 S1 equal to phi 2 into S2. So what that is equal to your total MMF. Say if that is MMF M, we write, then M by phi 1 or M by S1 is equal to your phi 1, and then m by s2 is equal to your phi2. So then phi equal to phi1 plus phi2, that we can write in the form of m by s1, m by s2. So if you take m common, then 1 by s1, 1 by s2. So if you take in m in the other side, then that is the effective phi. If we consider it is 1 by s equivalent. Same like with this same concept only I have solved, but just not straight away I have used this equivalent reluctance. So you should not, this is not approximation, this is the same thing which we are using and we are getting solving it. So you should get the same value. So please
Sir,
cross
what
check.
was your value? 3 point?
It is 3.3463. Okay. So this I'll share with you. I think with that you can solve it. You can cross check what is the thing, what are the value, what are the thing we have taken care of. Okay. Okay, so anyway, in the next class I'll solve it clearly with all these values and I'll share with you. Then things will be good.
Please share this PDF.
PDF. Okay, I'll share in PDF. Okay, fine. Okay, if there is no
Thank you,
other
sir.
question, then we can close today's class.